In this video, we are going to be covering a few things, some new things, and how to incorporate those things into a different way of moving things around on a scene. First thing we're going to cover is arrays in Unity, and I'll post a link at the bottom of this video so you can reference the Unity API. And how we're going to do that is we're going to learn how to declare arrays in Unity, how to initialize some values within an array, and then how to find the length of an array, assign the contents to an array, and then reference those contents within the array. From there, we're going to talk about the differences of move towards and lerp within Unity when you're trying to make an object move through space, and discuss the differences. And then the last one is how to use arrays that we've created to create waypoints that an object may want to move around in space, and then how to make it pick a random spot after we reached it. So a few things in this video, and we'll get through all of it. Cool. So the first thing that we want to do is talk about arrays and how to declare them. I'm going to move this out of the way, and we're going to create a new script. Your screen may look like this, it may not. That's okay. I'm going to hide a whole bunch of stuff so that there's less clutter for you guys to see. Okay, great. So you should just see like a blank platform or ground right now, nothing there. And what we're going to do is, let's just create a new object, a 3D object. Let's say it's going to be a cylinder. There it is. I'm double tap F, zoom in a little bit. I'm just going to elevate it up, elevate with green. There we go. So it's there above the ground. And what we want to do is, right now we don't need anything else attached to it, but we're gonna we don't need any other components except for a new script. So I'm going to make a new script, and we're going to call this arrays and waypoints. Make sure that this is all in one word. Now that it's on the object, let's open up MonoDevelop, and it should look something like this. I'm going to delete, not delete, I'm going to close some of these. Drag these away. Close, close. Okay, so we're just looking at this. Maybe I'll make this text a little bit bigger. Okay, great. So first thing about arrays is arrays are a way to organize a certain data type and be able to address the items within it based on their index. And so imagine it's like a catalog of a certain data type. Let's say maybe an integer or a string. Maybe you want to keep track of the days of the week, or numbers, the number of lives of different characters that we have, those types of things. And in this case, we're actually going to create an array of waypoints, and so they're just going to be objects in space that we're going to be moving towards. So firstly, how do we declare an array? It's going to look like a method that we've done before. So let's say that we want to create an array of strings, and so normally we write string, and then we would have, that's the type, right? And then we would have the variable name, and so like this would be regular string variable, something like that. And if we were to save that and build, we would go back into Unity, and how it would appear would be we would have one variable space, right? We just created just a regular variable, and then we could say that this could be Nick. And if we wanted that to happen, then we could just check the contents of it. We would just maybe say print regular string var, and that would just give us the one variable, right? So that's not an array yet, that's just a regular variable. If we were to run this and check the console, then it would just have Nick there, right? We can't have more than one string on there, we only have one. And so let's say that we want to create sort of an array of strings, or a grouping of strings. It would look similar, and we'd say type string, but in this case we'd write open and close square brackets, and that's the symbol to say, hey, this is an array rather than a regular variable. And so we're going to say that this could be array of strings. And so that's just the regular declaration of it. And so if we were just to create that and build and go into Unity, you would see that this variable should show up, and that's the name of the array, right? If we click this little triangle button, then you would see that says size 0 because we didn't give it an original size. From there, if we were to just interact with it in the inspector, we could say maybe the size is 5, and now we can say that these are names of something. Let's say that this is Earth, and then maybe Pluto, and then Mars, Saturn, and Mercury. All right, so we've created an array, and now this array has 5 string elements in it. And remember, an array can only hold one type of data. We can't put numbers in here, we can't put floats in here, it can only hold strings, right? And notice the way that it references the elements. It starts with element 0, so this is the first one. Element 1, that's the second one. And this is different than how we normally count, right? But the index starts at 0. And if we wanted to check on that, then we could, I'm just going to comment this out, and we want to see the third item in this array, then this is the convention of calling items in there. We would say array of strings, that's the variable name, and then we open square brackets, and then we pick the index of the array that we want to use. In this case, we want the third one, so we say 2. And if we wanted to have that printed out, then we would just wrap that up in the normal print method. And so before we hit play, I'm going to jump back into Unity. We said we want the third item in there, or index 2. And that's going to be Mars. So if we hit play here, Mars, there it is. Cool. So we just figured out how to get an indexed item in an array. I'm going to say that this is created an array of strings with name. You can see the name. And so this is just a regular string variable. Great. So we created an array here, and then we access the third item in the array. Let's talk about how if we wanted to initialize something. Let's say that we're going to make another public array, and we're going to call these to be integers. And we make square brackets, and this is going to be, let's say, numbers. And rather than stopping there after the simple declaration, we're going to initialize it. And the way to initialize it is that we would say new int, just like we have it here. We're just going to mimic what we have here, and we're going to say new int square brackets. And then we start out with using squiggly braces. This is something that we haven't done normally. And we're going to give it some initial values. 1, 3, 5, 7. Close that. And then let's see if we can access, or we can get the Unity to print out the third, the third item in this array. So we know that this is 0, 1, 2. And so when we want to access that, we'll go to numbers, open square bracket, 2, which refers to the third item in the array, and we expect to see a 5 when we run this. Hit run. Okay, I think what we've done is it doesn't like us giving the initialization in outside of the start, or in a method, a function. So we're gonna cut this out. Leave the declaration there, and then we're gonna assign those values here. So it's similar to how we had done it before, but we're just gonna reference that array and feed it in the start. Save build. Bingo, 5. Great. So we've learned how to declare several arrays now. Declared an array of integers. Let's not say created, let's say declared. Because at the moment this is just empty. We filled it in the inspector and then we filled it up in here. Last thing that we want to do is, we know that we can print a certain one, right? A certain number. But what we could do is, what's super cool and is on our agenda, let me grab that agenda, is to find a random number in the array, right? Let's say that we have this array and we know that we've looked at this has 4 items in it. And we want to pick random items in this array. And so what we can do is we can print out, we're going to print out something, and we're going to print one of these numbers from this numbers array. And we know that normally, what we normally do is we go numbers, and then we pick a specific number that we want, right? And then if we did this, and we wrap this all in print, then it would look like, we would know that it would spit out number 5, because that's what we just did. But now we want to print out a random number, and we're gonna do what we're gonna do is a little bit different. I'm just gonna eliminate print just so we're not confused about anything. We're gonna go random. This is a built-in Unity class, random dot range. And what range wants when we start typing this out is a min and a max. We want to pick, the whole goal is that we want to pick a random number from here, and rather than sticking in 1, 3, 5, 7, we want to use the index, and the index is 0, 1, 2, 3. That refers to the slot, so to speak, of the array, right? And so we want to randomly pick a slot and then get that number from that, right? The number from the index. And what we can do is we're going to say 0. We're going to start with 0. We want to randomly pick from between 0 and what? 0, 1, 2, 3, right? And we could do that, and that would work fine to pick a random number between there. And then we would stick that into our numbers array. In fact, let's do that. Let's print that and see what happens. Give you a second because I deleted some things. But print that out. We're going to comment this out. And so we would just expect to see Mars, and then we would see a random number here. Get out, play. Hit play now. And there that is. That's 5. Let's just change that number. Oh no, let's just run it again because it's just randomly picking. Now we have 3. Now we have 5. 5, 3. Okay, so we know that it's working. It's picking the random number in there, right? Let's just make sure if we go 4, are we going to get an error? 0, 1, 3, 7. Great. So one rule about using a random dot range is that if we use a whole number, this is non-inclusive. Let me drag over something that's super important for us. Let's say that you leave 272 and you're trying to do some game dev, and you know that you want to use range, but you forget what numbers are going in here. Quick tool to use is if you hit Command apostrophe on a Mac, then it should pull up a website that references that specific class if you had used it right. And so my internet's taking its time, but it's going to pull up that range It's going to search the range and try to pull up what you think you had. And so in this case, we use random.range, and you can click on that. It's going to give you all this Unity information on what it takes, right? And what's really important here is that we understand it's going to take a minimum and a maximum, but there's a note here that says returns a random float between, if we use a float number, it's going to take min and max. And you can see that this is inclusive if we use that. But the difference is if we use an integer, then it's non-inclusive. If you get on here, look at this. This says returns a random integer number between min inclusive, max inclusive. And what that means is that when we give it a maximum number here, it doesn't pick a number between 0, 1, 2, 3, 4. That would be inclusive. But in this case, it's non-inclusive for this max value, so it's actually going to pick a random number between 0, 1, 0, 1, 2, 3. Let's just make a note. Integer range max is non-inclusive. Just make a note of that floats and integers are different, and so you might be not using the proper range when you think that you are. Okay? Cool. So now we know that this is working. Let's just play it again. We know that we're going to get, it's going to pick a number for the index and then access that number within the array. We have 1, 3, 5, and 7. Just picking a random number between 0 and 3, and then it's going to refer to the array with that number, which refers to the index. This is index 0, index 1, index 2, index 3. Cool. So that works, and that's fine and all, but like one cool thing that we want to be able to use, and let's say that we randomly increase this array to a larger size. And now this 4 doesn't mean anything because we want to be able to access all of these. What we can do is there's a way to figure out the size of this array. And the cool thing is that arrays have a property that we can access. And in this case, our array is called numbers. And to access the size or the length of this array is we can just type in dot to zero in something more specific or access a parameter for an object, and that's going to be the length. So let's comment this out and let's test this out. If we try to get a return on this, let's say that we want to use that some way in our script. If we print this out, then we're hoping that it's going to give us the length or the size of this array, and the length of it is 1, 2, 3, 4, 5, 6, because we're just actually counting and we're not using an index. We start with 1, 1, 2, 3, 4, 5, 6, and so we hope to see Mars and 6. Yeah, I'm gonna get out of play just to make sure. Mars and 6. So the size or the length of this array is 6. So what's cool about this is that we always know, and let's just add another one to see if it's actually working, and this should jump to 7. Great. Now that we know the size of this array, we can use this as a way to get a random number from that array. And rather than putting in this magic number 4, because that would be useless. We would be only accessing these numbers over here. We want the whole thing. And rather than changing this to 7, that's dumb, let's add this number because this knows how large the array is. And so we can access all these possible numbers within the array. So from there, we're going to just get rid of this. And then this function is going to pick a random number between 0 and 7. 1, 2, 3, 4, 5, 6, 7, and then use that value to access the array and get that, and use that as an index to find the actual numbers in here. Three. Another random number, 1. Another random 3. 7. Great. 9. So we know that this is working. Perfect. Are there any other agenda items for the array? How to reference an item in the array, we know how to do that. that that's when we use this syntax of typically this. This is example of referencing an item, the second in an array. Cool. And this is one way initializing an array. Great. Cool. So now we know how to do a little bit of some things of arrays. And again, I'm going to post the link to arrays and array.length to give you some more information. Be sure that you are checking out the Unity API, because that's where all the actual Unity stuff is happening. Whenever you refer to any other tutorials online like this one, it may be talking about some things that are not relevant to your current project, and so you might be just learning to do something in a non-efficient way, right? And the Unity API is going to give you the most simplistic generic way of doing something, and not out of so-and-so's example game that may be a game that you're not building. Cool. So let's just go on and start working with the rest of our scripts. Let's just maybe just jump out of this. So let's just save this and we'll deal with this later. This is a good way to just save this, and since we commented it out fairly well, we can you can save this and reference this later. Let's get out of here. Close this guy. Let's go to our cylinder. I'm just going to remove this component because we don't really need it anymore, and we're going to create a new one. And this is going to be random waypoints. Create an add. And then we're going to open it up. Great. And what are we going to do? We are going to create an array. We're going to create an array of waypoints. And so in order to have waypoints, let's consider this. We're going to create two empty game objects, because we don't want these waypoints to be on the scene. Essentially, we want to put a whole bunch of waypoints and have this object randomly move between them as if it were on patrol. And so we're going to create empty and just move it around somewhere over to the right of my cylinder. And then we'll create another empty, and then we'll move it over to this side. Cool. So we know that when we're in the game, we don't see these empty game objects, right? And that's handy. But sometimes we just don't see them on the scene too when we don't click on them. And so one way to make them show up in the scene but not in the game, just so we can see where they are, is we can create a little icon for it. And what we can do is click one of the waypoints. Let's just rename it waypoint 1. And the other one's going to be waypoint 2. We're going to give these two waypoints an icon, and you can click on this little cube with the different colors. Click on the little triangle, and you'll see it says select icon. It doesn't have any, so it says none. So there's a few others that we can pick, but let's just pick like a bar, and that waypoint name is going to appear there. And again, this is only going to show up in the scene and not in the game, but that gives us some visual representation of that object without having to click on it. And so this is going to be waypoint 2, and I'll make that blue. Now we know where they are, right? And we don't have to select them to see where they are. If I wanted to move it up, around, you'll notice, of course, it follows. Cool. So now we have these two waypoints. We can see where they are. Cylinder is going to start here. We're going to go back into the script. And what we're going to do is we're going to create an array that's going to hold these waypoints. And waypoint is just something that we've used to describe those objects. And there's no actual waypoint object in Unity. But what's important about these guys is that they have a transform and a position, rotation, scale. But what's important for them is for this cylinder object and move between them, it's going to try to match its position with these waypoints. And we can use their transform information to do that. And so we're going to create a public transform, that's the type transform, an array of transform called waypoints. And what's important about these generic empty game objects is that we're going to use their transform.position later. But this is just an array to hold those waypoints. Okay, and so once we've done that, let's just save and build, and we'll go back into Unity, and we'll see that this now, the array now exists, and we're going to decide that we're going to have 2 waypoints. So I just clicked on that arrow, and it says size 0. The array has no size or no waypoints in it. We're going to hit 2, and we're going to just drag one and the next into those fields. Okay, so now Unity knows about the transforms of these 2 objects, and now we need to write some logic to have the cylinders start moving toward it. What's important for doing that is this is going to be an array that holds the waypoints. Okay. We know that our cylinder is going to be moving around, and at any given time it's moving towards a specific waypoint, right? And so we need to create a reference variable to hold the vector 3, or the position in space that we want our cylinder to go. And so we'll say vector 3 target point. Right now, in the scene in Unity, it doesn't know where it's going, but at one point we're going to describe where it's heading as the target point in space, and it's going to be a vector 3. And we know a vector 3 can be a way to hold an XYZ position in space. And so later in this code, we're going to point to where this object is going to go using this target point variable. Secondly, when we want to, let's add the comment, the current waypoint as target. From there, we're going to create a public float, and this is going to represent how fast we go, so we're going to call it speed. And for right now, we're just going to use a 1. And let's just stop there. Cool. For right now, let's just make the cylinder move towards one of our waypoints, and we're going to use 2 methods today. We're going to create a move towards function to make character move. And what that looks like is we're going to create a new function, and we're going to call it void move me. And you can call it whatever you want. I'm calling it move me. And this uses a very simple line of code. What we're making our character do is we're not adding force or changing the velocity. We're going to be updating its position. So it's going to be moving moving in a certain direction in update. So we're going to access the object's transform.position because we're updating that every time we call it. And then what it's going to do is we're going to use vector3 dot move towards, and this is a built-in Unity function that takes 3 parameters. One is it wants the current position of our character or the cylinder that we're using, the target or the waypoint that we want to move towards, and then a certain speed that we're going to be moving at any given time. So this is really super simple. We need to give it a starting point or the current point that we're at, and this is going to be represented as our transform dot position. This is the same thing as game object, which refers to the object to which this script is attached to. Game object.transform.position. Same thing. So transform.position, and then it says that it wants the target, and we're representing that as our target point. And then we're going to give it a certain speed, and what we're going to use is time.delta_time, so that we have the same amount of speed that we're moving from different machines based on beefier CPUs, and multiply it by our speed. And since we're using this variable, we're able to control how fast it moves if we realize it's too slow or fast for us. Lastly, we're going to use move toward or move me and call that with an update. If we don't call this an update or start, then it's not going to move ever. Okay. Lastly, let's assign the target waypoint, because that's what we're using for the second argument. It doesn't know where it's going at the moment, and so we need to assign that. And so we're going to use a simple calling of an index point within our waypoints array. And so I'm just going to specifically pick the first one. For right now, we just want to be moving towards towards the first waypoint. And since we know that this is a transform holds three factors: position, scale, and rotation. Unity doesn't like it that we just are using the transform information. We have to put position right there. Otherwise, it's going to be wanting to feed it the transforms scale and rotation as well, and it doesn't like that. Okay, so at this point, we have a couple variables. One's an array that's holding waypoints, one's that's going to hold our current target at any given time, and the speed at the moment. From there, we're assigning our target variable to be the first one in the array. Lastly, to make everything move, we're going to be updating our cylinder's position with this function that's going to know where we're starting, or current position, and the end target point, which is a vector 3 in space, by going a certain speed. Let's go ahead and hit play, and we'll see what happens. You'll notice that our cylinder starts moving, and if we go over here, you can see that it moves. Once it gets there, it stops. Great. So at this time it works, right? But the end goal is that we want to have our cylinder move from one waypoint to the next, and then maybe if we have more, then it's going to go to the other ones, right? And so what we're going to do here is that we want to do two things, and I'm going to make some comments for it. We're going to we need to create some logic to let us know when our object reaches this guy, and when it does, when it gets real close, then we want to switch to the next, right? Because we don't want to sit here and pause. Maybe you do, but we want to know. This is one way to figure out how, if we've arrived at one of these objects or not. And what we're going to do is compare the difference in their positions. And we need to have a certain threshold, because sometimes the object doesn't move cleanly all the way over here before moving back, or it doesn't know that maybe it's really slow to get to the last part, and it's not perfectly in the target position. And so we need to create what we call a threshold. And to say that, oh, it's close enough, we'll say that it's there. Let's move on to the next one. And so we're going to create a variable, and we're going to call it public float. It's going to be a float value, and this is going to be the distance threshold. And this is going to be a number that we decide to say that when it's close enough, we're going to consider it arrived at the target. Distance threshold. Great. And once it reaches the target, or it's less than the distance threshold, then we want to pick a new target. And so we're going to write two functions now. we're going to create void change target. And from here, we want to assign a new target, right? The end goal is we're going to have target point be something else. That's our goal. And what we can do is we're going to use the functionality that we had written before. We're going to randomly pick a number from our array. And so we're going to create an integer, and we're going to call it random index. This is going to be some type of integer number, and we're going to use random.range to pick from the size of our array. And right now there's only 2 items, right? And it could be 10, but we're going to use random.range and say, starting from 0, we want to pick a number between 0 and waypoints dot length. This is the same logic that we had before. We're using integers, so this is perfectly fine. It's going to pick a number between 0 and the size or the length of the array, and then stick that into random index. From there, we're going to say we want to access waypoints, and the one that we want to access is that random number to act as the index to find that certain waypoint. And then it's going to assign the position to our target point. And so we're going to imagine this guy moving over here, and then once it gets less than our threshold to say that it's close enough, it's going to randomly pick between the other items in our array and then make our character move towards that one. The last thing that we want to do is we need to do that math that we said, right? So we have a threshold that we have, and we want to say that when our distance between here and there is smaller than our threshold, let's say that if it gets here and maybe that's the goal there, then we'll say that's good enough, right? But we need to do some math to figure that out. And what we're going to do is, this is how we're going to do it. I'm going to say if. We're going to create a condition, and we're going to say vector3, and we're going to use a built-in Unity function. It's going to be called distance. And distance takes 2 factors. It's going to be the distance between A and B. A is going to be transform dot position, and that's the position of our cylinder. And the second one is going to be our target position, because that's the one it's moving towards, right? And if that value, the distance between it, is less than our distance threshold, we want to do something. We want to be calling that change target function. It's saying that we're close enough, let's go ahead and change our target. Let's try that. If you find that this guy is moving slow, and it might be, we can go and change that speed that we had. Oh, so do you see that our character didn't change speed? It's because this object, like we said, isn't perfectly on top of our waypoint, and we have the value to be 0. So we're saying that if the distance between our waypoint and our cylinder is 0, then it should be changing, but it's not perfectly on top of where it is. And so what do we have to do? We need to give this a really, really small number, and it should be good enough to make it go. You can see that once I changed it, and instantly realized, oh, I'm within that range, and so I'm going to call myself there. And then it calls the change target, and then the new target is this guy. I'm going to increase the speed so our cylinder moves a little bit faster, so you don't have to sit here all night. And so it's going there, it's checking the distance, and if the distance reaches a certain threshold, it's going to switch to the next one. And voila, we're moving between 2 random waypoints. And what's cool about 2 random waypoints is that it's not going to, if it picks this one while it's right there, it's going to say, oh, we're already close enough, we're going to go to the next one. And go back and forth, back and forth, back and forth. It's not going to end up getting stuck. Because we've made the threshold a certain value, it's going to go to different waypoint. So let's just check this magic that we've done. Let's go ahead and create another waypoint. I'm going to go create empty, and I'm going to move it up here. Maybe I'll make it, let's see if this works. Let's see if we can make this waypoint up in the sky. And since we don't have a rigid body and we're not using gravity at the moment, let's make this third waypoint up in the sky. Let's do the same thing that we did before. I'm going to add an icon to it. Let's make it orange for me, and I'm going to call this waypoint 3. Save it. And the last thing that we want to do is, even though we've made these waypoints, we want to make sure that the cylinder is aware of them. And so right now we have 1 and 2 in our array. We need to change the size so it's 3. And then we're going to drag in that third waypoint into our array. So now you can see waypoint 1, 2, and 3. We're going to make sure that this threshold value is a small value. And let's make sure that speed is just a little bit faster than it was before, so we don't have to wait. Now our cylinder is randomly going, and you can see that it did go up in the air to where that waypoint was. You can see that again. And then it's going to the other waypoint. Cool. So that is most of the assignment. I'm going to get out of play. The last thing that we want to do is talk about the different type of movement. And you can see that this was really smooth, right? It's adding a certain amount to the position every time, and we don't feel like it's jerking anywhere or like it's moving faster or slower at the start. Let's talk about a different way to make our character move. And this is what's cool. You want to add a bit of character sometimes to your objects moving. You can do some way of scaling the movement, and so it seems like it's faster or slower at the start or at the end. And what this uses is going to be something called Lerp, and we're going to create a function called Lerp me, and inside there we're going to use the Lerp functionality, and it's going to look very similar to this move towards. So like you'll understand this logic completely. But in a nutshell, Lerp is a linear interpolation. And what it does is it's going to make it seem like this object's going to move quicker at the start, because incrementally what it does is it's going to judge where it is and then move towards it a certain amount, and as the value gets smaller or the distance gets smaller, it's going to move just slightly slower. Here's one way of using Lerp. We're going to use transform.position. It's going to look so similar to this other one called move me, right? Transform.position equals vector3 dot lerp. And then we're going to feed in the same values. And so I'm just going to actually copy paste this. It's going to be transform.position waypoint. And what it wants is, of course, its current position, the target, or the waypoint that we're heading towards, and then a certain speed. Now that we've written that function, let's say a lerp or linear interpolation way of moving character. Great. So I'm going to come here. I'm going to comment out move me because we don't need to use that anymore. We just want to use the lerp me. Save that and build over here, and then we'll see if we notice the difference for when our character moves. So it's a lot faster, but let's slow it down so if we can see if we notice the difference. You should see that it's at start it moves quicker and then slows down a little bit. And maybe you want a game where that happens. Let's see. Okay. Just notice. See if we can see how it moves. Cool. So one way to check this or make this more fun, right, is let's make another cylinder. Let's make 2 cylinders. So I just hit Command D to make another cylinder. And I'm going to actually give it the second cylinder a certain color. Where are you? Second cylinder. And I'm going to give it a blue color. Second cylinder is blue. First one is going to be green. And the second cylinder, since we duplicated, it already has the waypoints on there. And all that good stuff. If you need to do that, I'll give you a second. Copy those guys in there. Speed, distance has to be something. A distance threshold has to be a certain value. Let's see if we can have these guys move. Of course, each of them are randomly picking different waypoints, and so they should be moved to different ones. Let's make this fun, and what can we do? Let's see. We're going to make one move at a different speed, maybe? That might be fun. And if you don't like the cylinder, then maybe we can do a platform. Cube. Let's make it a certain size, 10. And maybe you're making a game that has a platform that wants to move that way. And we're going to drag what do we call it? Random waypoints. We're going to drag it into cube. Oh, it doesn't like it because we didn't put all the good stuff in there. We need to put the waypoints, 3 waypoints. If you don't have the waypoints in your array and you have some logic that's trying to access the array, a typical error that you're going to see is that an index out of range exception. And again, we said index is the slot number for the array, and so if it says it's out of range, that means that either you don't have the slots available, or you're accessing an index that doesn't actually exist. And so we didn't have an object that existed in the array, and so that's why we have this error. It's important to figure out what, or decode what these error messages mean. You can see that our platform also is going to be doing its thing. And the distance threshold is not big enough, so now it knows when it gets close. You can imagine a 3D game where your characters need to jump on some platforms and it waits or it slows down for things to get on, and then it slides off and does this thing. Did we cover everything? I think we did. This should be good enough for you to figure out how to finish the assignment. Good luck. If you have any questions, please email me. If I don't see you again, I'll see you Monday. Have a good night.